Hello and welcome to It Depends. Today we're going to talk about event-driven architecture. So I wanted to just kind of give an overview and some of the historical precedents from my perspective. So we'll start back. We'll go back in time and talk about programming in the late 1990s. This is right around when the first versions of Windows came out, 3.11. Can't remember. I think 95 was just kind of coming out, but um, Microsoft came out with a product called Visual Basic. It was kind of one of the first WYSIWYG foreign business application designing programming languages. It was awesome. I loved it. Had a bunch of great features. One of the primary features around that was this concept of event driven programming, and what that meant is you would essentially have an application and then you would write code around what to do when certain event happens. So let's just say I had a form on the screen, had a button. When the user clicked the button, maybe I wanted to pop up another form or display some information in a dialog, go do a lookup in a database, something like that. You would respond to the click event. A basic eventing has propagated from there because it's an extremely useful pattern. We use eventing every day in most of the programming things we do. And so that's kind of where it started, where we got this idea of this concept of we're going to provide you a framework, and inside that framework, we're going to let you customize what happens when someone clicks the button, when the form loads, when the form unloads, and we're going to give you these lists of events, and you can subscribe to these events, and then you can take actions when you get notified that those events are occurring. So that's the idea behind event-driven programming, right? And we use that today. JavaScript, jQuery, you're subscribing to the click event. You get a notification when the button is pressed, and you take some action on the UI or the DOM. Maybe you send a request to the to maybe you send a request to the server to give back some data to display on the page. But we do a lot of event driven programming, and I think a lot of times it's just kind of something we do and we don't really think about it. But that pattern as a whole can be extended. Some other existing kind of event driven features in current web design is the concept of webhooks, right? So when an event occurs in system A, I system A, let's just say we're because we're going to use warranties as an example because that's an area that I'm familiar with, and I think it illustrates the idea well. So uh, 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 you're working on an external system that has webhook notification capabilities, and you subscribe to the webhook and you say call this URL whenever a warranty is registered. And then the webhook will call your URL and most likely post a little bit of data to you, and then you go and do whatever work that you need to do when that event is fired. So that's kind of the concept of webhooks, right? So that plays into the event driven architecture. You're basically subscribing to an event notification from your provider when certain things occur in their system so that you could take appropriate action in your system. So that's kind of the whole idea behind event driven. And notice these systems are separate, right? And they don't really care about each other, and they don't really necessarily know about each other. All system A knows is when a warranty is registered. If I have any webhooks that have been set up for notification, I'm going to fire this type of notification message over to this URL. And in some cases, it doesn't even matter if the URL responds. It'll just post the data and then kind of walk away from the transaction. So it's your job on system B to respond appropriately to that event and take the actions that you're interested in taking. So that's a current example of across the webs of kind of this event driven architecture, right? It's and like I said in the previous statement, it's super powerful. So there's a lot you can do here. And so now we move on to the topic du jour, which is the architecture pattern of event driven architecture. The key components in my mind of this pattern are we have Multiple systems. You can do this in the same system. However, I think there's probably better messaging patterns if you're in a module, if you're doing like a monolith, or if you're in a modular monolith, or that kind of thing. Where this can really shine is if you have patterns where you have to do a lot of processing, and you'd like that processing to be handled kind of in async manner, kick off the process, get notified kind of when it's done. That's a good implementation here. And the key components of this are the system that is the publisher of the event. These are the events that I have in my system. These are the events that I'm going to send notifications for. Usually you'll have some kind of messaging or event bus in the middle where the publisher, this just handles all of the engineering around doing these notifications, gives you built-in fail-safe and that capability. I mean, you could definitely kind of roll your own event bus, but there are some very robust event buses out there that, I would be hesitant to kind of roll my own in in most cases. So event or system A is exposing a series of events. And there's going to be your event messaging bus system, which is where the events get published. And then you have system A, B, C, D, however many systems are interested in that event, they subscribe. So it's kind of a message publisher subscription model, right? But we're talking about events because we're not just sending messages, we're sending event messages here. So something happened over here, and we want to notify this other system over here. So how that so anyway, so we have a message that we have an event, and we're going to use the warranty registration example. So we have an event where the a warranty has been registered in the system that is sending out the notifications, right? And that message is going to be sent. It's going to be placed in a queue. Now, the interesting thing about these messages are we're going to have the event, what event occurred, right? Because we can have multiple events, and we want to be responding to the right ones. Now we could set up multiple message queues for messages and have everyone subscribe to the different messages they're interested in. We could also use a unified messaging format where we specify, it's a little less efficient, but where we specify the event that occurred. So we're going to say that a warranty registration occurred, and then we're going to provide some type of payload. Maybe we provide the warranty ID, whatever information that the receiving system is going to need to be able to take action. Let's say that our receiving system that's interested in is the accounting system. So the accounting system is going to get notified that a warranty was registered, and it's going to get notified that a warranty was registered, and then it's going to take a series of actions. So for those of you who are unaware, when you purchase a warranty, it's the same model as insurance. So you're purchasing extended warranty for a vehicle, and then the cost of that warranty is broken up into the different insurance buckets. So, for example, if we're doing something like appearance, maybe there's something that protects the leather, something that protects the external paint, and so it's an appearance type product. Well, when you buy a warranty, a certain portion of that warranty amount goes into each one of those insurance buckets, and when claims are made, they're made against that account, right? So I have a claim for my appearance. I got a scratch on my car and I want to get fixed, so I make a claim, and then the money is pulled out of the pool, just kind of the general insurance concept. So when the accounting system receives the warranty creative message, it's going to go out, it's going to look up the warranty information, look up what type of warranty it is, and figure out how to allocate the funds that were assigned for that warranty into the appropriate accounting buckets, so that the money is placed in there and is available for claims to be made against. And so the reason why this pattern is so nice, and why it's a great architecture, is because the systems are completely independent of each other. As long as I don't change you can consider it kind of an interface or a subscription interface for my messaging. Generally you can add things, but generally you don't want to remove, because then the receiving system has to make changes. Maybe later on you come up with a new message, you're including a little bit more information, and the accounting system is not quite ready to receive that, it can still receive the original messages, pull out the information it needs, and do that kind of lookup. Again, like the name of the show, it depends. Like, but as, in general, right? You're gonna send messages, and then those messages get picked up, and then actions happen in other systems, and they're decoupled, which is which is kind of a nice pattern. So that's kind of event driven architecture kind of overview. So you have multiple systems that you want to respond to. We'll call them enterprise events, right? Because if my business is processing and receiving warranties, processing claims, selling extended warranties for vehicles, then when a warranty is created, that's kind of the kickoff, and everything gets registered and money gets moved where it needs to go, and invoices get sent out, invoices get paid, and then funds get allocated into the correct buckets, the correct insurance buckets. So most of the enterprise is going to want to know when a new warranty is created. You could even have system B, which is maybe the claims system, also gets a notification. Maybe claims is handled in something like Dynamics or Salesforce or another type of product where you've built your claim management system, or you're on another platform and you just need to be notified that a customer has valid warranty, right? So if they immediately call up 24 hours later, or whenever, and then they're like, hey, I have a scratch on my car, I want to get fixed, then you can immediately start working on that information, because all the systems were notified that that warranty was created and registered. And maybe the accounting system sends out an event notification for when the warranty is funded, right? So the we invoice the dealer's paid the cost for the warranty, and now the warranty the warranty area of the system, the website, whatever it is, it gets that notification. And then when a dealership or dealer group logs in, they can see that the status of the warranty is active, right? And neither of these systems understand the internals of the other systems. We just know that, hey, if we get this notification from the accounting system that the warranty is funded, we want to display the status over here. Another awesome use for kind of event-driven architecture that I really like is real-time dashboarding. So with real-time dashboarding, you basically have whichever systems you want to participate in the dashboarding, whatever metrics that you need to collect for your organization. You build an eventing system, and that eventing system is collecting those messages. Warranty registrations, we've had 500 today or 1,000 today or something like that, and you have a real-time dashboard, and that dashboard is getting sent those messages, and those messages are basically getting counted. Or you're showing total warranty sales for the day. Maybe you got a big huge display, and everyone could see like, oh, we've done $50,000 in warranties today or whatever. And so for real-time dashboarding, it's kind of nice too. And as a tie-in, I want to just briefly mention that you can combine architectures, right? So I know that's kind of obvious statement, and probably everyone who's listening to the show is aware of that. But these architectures can be combined. Like if you take the hexagonal architecture pattern that we were talking about yesterday, you can build your system out, and then you could add modules or services or DLLs or however you want to register those into the system that provide this eventing, that basically subscribe and publish in these events without changing the core piece of the application, right? So, and actually you'd probably have to change a little bit in the core area, because you need to be able to let the eventing subsystem know that a particular event occurred, but the changes would be minimal, right? Because we're saying, hey, when this happens, also send this notification over here, and then that piece of the hexagonal architecture will go out and will take care of interacting and publishing it, and then consuming and notifying any events that you have in that. So you can kind of stack these two architectures together. And I like to think about, when I'm designing or implementing kind of an event-driven architecture, I kind of like to think about it as like enterprise events, right? So we want to publish events because other systems that we don't want to tie directly together need to be notified when state changes happen in our existing system. So that's kind of like an overview and kind of the history and just the power behind events. So if you're not thinking constantly in terms of of events, it's something to consider because there could be events happening in your enterprise that allow you clean hooks in to get notifications, to take actions, automated actions, mind you, on in other systems. So if I was designing, like I said, if I wanted to hook in a warranty registration system with my accounting system, this would be one of the primary things I would consider would be what does my eventing system look like? Like how can I let this system over here just do what it specializes in, and this system over here specialize in what it does, and then I can share information across these two. And this is a great pattern for allowing that. And they're completely decoupled. They don't have to be, right? You could still be doing event-driven architecture and maybe the webhook example, right? So we go back to that. That's event-driven architecture, but there's no message queuing piece in the middle. The message queuing piece is basically there as kind of a way for you to stack up and store events. I know Kafka is really big right now, and you can store these messages. You can do different things. You can publish to multiple subscribers. There's a bunch of very neat features you can get by moving to an event messaging model, but you don't have to do that. Like a webhook is going to call your URL and pass you a little bit of information. You just set up that endpoint and you respond to it. So you can definitely do this architecture and still have the minimal evasive interconnection with just the two systems directly, right? But then the system B kind of comes a little bit dependent on system A, and so if you want to avoid that coupling, then you stick in that messaging piece in the middle. So that's kind of a overview of event-driven architecture. I appreciate everyone's time today, and I hope you all have a great day. And we will see you tomorrow. And enjoy the rest of your day.